My name is Sonion. I'm a manager of development support services at Sonion in Sonion NL, which is a Danish company by origin. We're located in Holland, and we have a very big research and development department, and we are developing parts for hearing. We mainly focus on like transducers, which are the parts in the hearing aid that collect the sound and produce the sound. But they're all very tiny components that fit into the hearing aid. So we have to make very small parts. In the past, we made most of metal. But in development, because you want to really determine sizes and if they work okay and mechanical properties, it's nice to do very quick iterations, and therefore we introduced 3D printing in our R&D development. So everything is like millimeter sized. It has very intricate little details, let's say, and also if you look at, so it's a cylinder and it has very small wall thickness. And I have also an example for you for what we have like 3D printing in-house since 2016, and we have also other machines. And when we tried printing with very small wall thickness, you see that they collapse. So when we have this kind of products, we cannot do anything with it. So that's why we ended up with BMF, because you have the capability of now we have the capability to make these small wall thicknesses. Especially what you see, this is quite a large height. This, yeah. So the thin wall, in combination with thin walls and large height, is really something that we did not. We were not able to reach with our previous 3D printing. Of course, we use injection molding, but for prototyping, injection molding is very expensive because we have to first build a mold, and tooling is very expensive if you are in the iteration process where you have to make changes still to the design. Yeah, for every new design, you have to also change the mold. So it's very expensive, and it's also time consuming, because also for a proto mold easily takes 4 to 6 weeks to build. And 3D printing is just, yeah, you have results within a day.